we have an integral 0 to half pi of arctangent of a times tangent x over tangent x dx. I'm going to denote it as function in terms of a. And first, I'm going to differentiate with respect to a. It's legal for me to do that. Right, first, I'm going to differentiate, then I'm going to do the integration. So the integral from 0 to half pi. Again, tangent x is just a constant. Then it's arctangent, it's derivative, right? So I'm going to multiply by a squared tangent square x plus 1. Then it's the chain rule. Now, tangent x is just a constant times tangent x. Then dx. Tangent x cancel out. Now I'm going to let tangent x equal to t. So therefore, x is equal to arctangent of t. So dx is equal to 1 over t squared plus 1 dt. And so when x is equal to 0, t is also equal to 0. Right? And when x is equal to half pi, t is equal to positive infinity. So the f prime of a should equal to 0 to positive infinity of a squared t squared plus 1 times t squared plus 1 dt. Right? And that is equal to 0 to positive infinity of some constant over a squared t squared plus 1 plus some other constant over t squared plus 1 dt. And that constant, I guess, perhaps I'll use a squared, right? So a squared times t squared, a squared t squared. Maybe I just use minus 1. So minus 1 and a squared t squared, they just cancel out. Still have a squared minus 1. Just multiply by its reciprocal. That is 1 over a squared minus 1. Of course, I require a not equal to positive 1 or negative 1. So that we're safe. And in this case, that is equal to 1 over a squared minus 1. And it's a squared that's constant. Right? So this time integrate with respect to t. So this time a is a constant. A squared times arctangent of at. Right? So to double check, to differentiate this, still I'm going to have a squared t squared plus 1 at the bottom. But I'm going to have to multiply by constant a. Right? To cancel out the constant a, I have to multiply by, I have to divide by a. Right? So that becomes just a. So a times. Right? So that is minus arctangent of t. And evaluate from 0 to positive infinity. Okay, so that is 1 over a squared minus 1 times. So of course I'm going to have to, so different case scenario. So when a is positive, right? When a is positive, then if t is positive infinity, then it's still positive infinity. Right? So this becomes half pi. Right? So it's half pi times a. And this is fine, right? Just minus half pi. And 0, 0, so arctangent 0 is just 0. Still 0, so no more. So just this. That is equal to half pi times a minus 1 a minus 1 times a plus 1. That's 1 over a plus 1. Right? So that's when a is positive. So when a is negative, that is equal to, so here is when a is positive. And so when a is negative, that is equal to 1 over a squared minus 1. This time, right, negative number times positive infinity, negative infinity, so negative half pi. Right? Negative half pi times a times this is the same, right? Don't worry about it. This still minus half pi. Right? So 0, 0, substitute here. 0 goes in here. 0, 0, don't matter. Right? So this is fine. So take out the negative half pi. I have a plus 1. So a minus 1 times a plus 1. So it's 1 over a minus 1 this time, when a is negative, of course. So generally speaking, when I use theta, right, theta as a if I say f prime of theta, right, so theta is f prime of theta is equal to half pi times, just replace a with theta. Theta positive, theta negative, right? So it doesn't matter. So in the end, I still have f of a minus f of 0. That is the definition of definite integral, right, from 0 to a. Right, I'm going to use the antiderivative, right? So d theta. So half pi times 1 over theta plus 1 d theta when theta is positive. So when a is positive, right, this time when a is positive. So when a is positive, that is equal to what? Half pi log of a plus 1, 1 plus a. Don't need the absolute value because everything is already positive, right? 0 log of 1 just 0. And also f of 0 is what? F of 0, 0, right? So that is just f of a. And when a is positive, right, equal to this. So when a is negative, what do I have? I have negative half pi. When theta is negative, I'm using theta, right? Theta, 0 to a. And 1 over theta minus 1 d theta. Right? This time theta is negative, and also a is negative. Of course, from integrate 0 to lower bound, upper bound, 0 to negative. Of course, theta is negative this time. That is equal to negative half pi log of course, this time I'm going to use the absolute value. And to use the absolute value, theta antiderivative, theta minus 1, theta negative, so everything, whole thing is negative. To use the absolute value, I'm going to have to change the sign, right? So just 1 minus theta. from 0 to a this time. And so that is equal to negative half pi times log of 1 minus a minus 0. And so this when theta is negative, also a is negative. So when a is negative, negative a is positive. So it's 1 plus some positive number. Right? 1 plus some positive number. Maybe combine them together. Right? Maybe I can write SG and sine function, sine of a. Right? Meaning when a is positive, function is 1. Positive 1. When a is negative, function is negative 1. When a is 0, this is 0. So sine of a times half pi times log of 1 plus absolute value of a. Okay, like I said, it's either going to be positive or negative, right? Depending on the value of a. A is positive, it's positive. A is negative, it's negative. And also the inside of the log, we have something always positive. Right, so 1 plus a. This time a is positive. So that's equivalent to 1 plus absolute value of a. And here we have 1 minus a, but a is negative. So 1 minus some negative, so 1 plus some positive number. Right? It's equivalent to 1 plus absolute value of a. Right? It's the same. So also depending on the value of a. Like I said, if it's positive, then we have positive 1. If it's negative, we have negative 1. Right? If it's 0, we have 0. Right?